Shalom to you and welcome. In this video, we'll be looking at properties of parallelogram. So we'll apply the definition of parallelogram, use the theorems about the properties of a parallelogram to solve problems, and then discuss how to prove that certain quadrilaterals are parallelograms. Quadrilateral is any figure again that has four sides, quad, four, lateral, line, four sides, four lines. All right, definition. A quadrilateral, definition of a parallelogram is the quadrilateral whose opposite sides are parallel. So once we have any four-sided figure and their opposite sides are parallel, that is the parallelogram. And even from the name, parallel, the name parallelogram. So both sides has to be parallel. AB is parallel to BCD and BC is parallel to AD. And if in a proof we use a symbol, a small size of a parallelogram to show to the word, to replace the word parallelogram for shorter form. So a parallelogram is named by using four vertices. The vertices you can name parallelogram A, B, C, D. You have to name all the vertices. Or you can go A, D, C, B. But you have to go in order. If you want to go clockwise, keep clockwise. If you want to go counterclockwise, keep counterclockwise. You can't say A, C, D, B. No. Okay, it has to go in order. Now, properties of parallelogram. By definition, their opposite sides are parallel. By definition, opposite sides are parallel. But also, the opposite sides are congruent. They are not only parallel, they are congruent to each other. They have to be equal to each other. And then the opposite angles are congruent. The opposite angles are congruent. And consecutive angles are supplementary. When we make consecutive in order, if I pick this angle and this angle, you add them, you get 180. It's supplementary. So this angle and this angle here would be supplementary also. And that makes sense because think of it. If this angle here plus this angle here will give you 180, and this angle here plus this angle here will give you 180, because they are same side interior, because these two lines are parallel. For this part, because these two lines are parallel, they are same side interior. But also, if these two are supplementary and these two are supplementary, that means these two must be equal because this angle here is equal to itself by reflexive property. Remember that theorem. If a pair of angle is supplementary to another pair of angle, then those other angle must be congruent because this has to be itself. Okay. The diagonals bisect each other. So diagonals bisect each other, cut each other into half. So this diagonal will cut the other diagonal in half, and this diagonal will cut this one in half. And then the diagonals form two congruent triangles. So if I cut this, it's going to be congruent triangles. Why? Because you think of it, this side is congruent to this side, and this side is congruent to this side, and this side is congruent to itself. So by side, this triangle is congruent to this triangle by side. All right, is this a parallelogram where we know it's four-sided? We don't look by self. Nothing tells us the sides are congruent or the sides are parallel. Nothing tells us that. But we can look at the angles. This angle B is congruent to angle B here. So they are in color. Identify that they are congruent. A is congruent. So opposite angles are congruent. So yes, because opposite angles are congruent. How about this one? We can't tell by the sides again, but the diagonal says something. that this diagonal bisects this diagonal into half, because these parts are congruent to this side, and this side is congruent to that side. So it bisects each other. Yes, it is parallelogram. How about this? Is any of these a parallelogram, a rhombus, a rectangle, a square? Again, don't just jump into conclusion. Look at them closely before you respond. Do they meet the requirement? What do we know about a square? Opposite sides are congruent. Yep, opposite sides of a square are congruent. So that alone makes it a parallelogram. And so every other property that a parallelogram has, a square must have it. How about a rectangle? Yes, we know that opposite sides of a rectangle are congruent and parallel. So that makes every rectangle a parallelogram as well. How about rhombus? Yeah, we know that all the sides of a rhombus has equal side, just like rectangle. Just like square. Actually, this should have all the sides should be equal. So yeah, so both sides, opposite sides, if all the sides are equal, that means that opposite sides are equal too. So, and they are parallel. So yes, these three are parallelograms, each one of them, and actually they are called special parallelograms, and we will take time to look at each one of them later. So find the measure indicated in each parallelogram. So what do we know? Well, we know that RT here is 19.8. So that's half. We are asked to find RP. RP is the whole length. So what do we know? What's the relationship between RT? If it's a parallelogram, so it means this side must be equal to this side, because the angle is going to bisect that. Therefore, but we are looking for the whole length here. Okay, so we know that RT is 1/2 of RP. If RP is 1/2 of RT, that means RT is twice. That means RP would be twice RT, right? Double it. So because if you multiply both sides by 2, that makes RT twice. So what we just replace RT, and then multiply. What is that? 2 times 8 is 16, so we get 39.6. So RP would be twice the RT. Okay. Next, find the measurement indicated in each parallelogram. Okay, what do we know? Well, we know they are on the same side here. Consecutive angles of parallelogram are supplementary. So we know that angle C plus angle EDC. So this angle, all of them, is equal to 180. So we're looking for this angle alone, though. We can label it X. So we know angle C is 55 plus angle EDC is 62 plus X together, and equals 180. So we can add those two together. We get what? 117 plus X equals 180. So subtract 117 from both sides. So X is going to equal 63. So since X represents the angle that we are looking for, then we are done. That's the measure of that angle. But if we are given the whole angle, then we have to subtract to find X. Okay. Next, we have to find the lengths of TS and UR. Well, this is a parallelogram. Opposite sides are congruent. So we know that TS must be equal to RU. So TS is 2x plus 15 equals x plus 15. So for x, subtract 15 from both sides, we're going to get 2x equals x. Well, we still have to collect like terms. So if we add x, we're going to get 0. So substitute 0 here. 0 plus 15 gives you 15. 2 times 0 is 0 plus 15 is 15. So that confirms that both sides are 15. They have to be. It's a parallelogram. Okay.